Before we can start replication and configuration, we are going to ensure all objects are correctly journaled. For this demo, we will work with several libraries and some IFS content which has not been journaled to this point. First, we will create the objects required to start journaling. Then we can start journaling the objects, and finally create the remote journals. We can start by taking a look at the libraries we will use for this demo. We will work with two libraries, Bravo DataLib and Bravo ProgramLib. Also, in the IFS, you can see we have some additional content and files. We will be journaling all of these objects. The first thing we are going to do is create the library to hold the journaled objects. Next, we can create the message queue. We recommend always using a naming convention across all the objects when journaling. This will make everything easier to track and organize. We also need to create a journal receiver. For this, we can take the defaults. Now we are able to build the journal using the journal receiver and message queue we just created. We let the system manage the receivers as we do not want the journals to be deleted automatically. We can leave the other options as default. Once we have created a journal, the next step is to start journaling the objects. So let's take a look at the contents of one of the libraries. In Bravo DataLib, we have data queues, files, and a couple of data areas. To start journaling against those objects, first, run the start_journ_pf command. Enter *all to journal all of the files in Bravo DataLib. Enter *after for the record images. If rollback is required, you will enter *both, but for most clients, using *after will be sufficient. We will omit the open and close entries as they will not be used, and leave the login error field as default. This has now started journaling on 31 files. Because we want to journal other objects such as data areas and data queues, we will have to use the start_journ_obj command. As before, we want to start journaling on all objects in Bravo DataLib. This command will have to be run for each object type individually. First, start journaling the data areas, using all the defaults. And now we will do the same for the data queues. Now that we have done the files, data areas, and data queues, the next thing is to start journaling the IFS. We will run the start_journ command. Enter the directory we checked at the beginning of this demo. For the journal field, we will have to enter the full path to the journal we just created. Next, page down to change the Inherit New Objects field to Yes. This will make any new objects that get created pick up this journaling. Images we will leave as *after, and we can omit the open and close entries as well as the symbolic links just as before. You will see at the bottom that this has added 5 objects, meaning that all of the objects have been picked up from within the subdirectories. To view our progress, we can run work journal attributes on the journal we created. Once here, we can press F19 to display the journaled objects. Choosing option 30 will return all object types. These are all the files we have journaled. There are no access paths at this point. These are all the data areas we have started journaling, the data queues, and finally the IFS content. Now that all of the objects have been journaled, we can create the remote journals. Now we must move to the target system. We will start by creating a library where all the remote journals will reside. We will call this library BravoJourn@R. We use the naming convention @R to dictate that this is the library for the remote journals relating to BravoJourn. The only object we need to create at this time is a message queue. The name will match the message queue we created earlier on the source system. Another thing we need to set up is the remote database directory entry. Running the workdbdire command, we can see that the local database entry is called SAS6, and we have already created a database entry for SAS5. This will allow us to go back the other way. Moving back to the source system and running the same command, we can see that we have already set up SAS6. These can be added using option 1 and entering the system's IP address as the remote location. Next, we will run the work journal attributes for Bravo Journ. Pressing F16 will display the remote journals. As you can see, there are currently no remote journals. We will have to create a new remote journal using the add remote journal command. The relational database will be SAS6, which we looked up earlier. The source journal is Bravo Journ, and the target journal will also be Bravo Journ, but this time within Bravo_Journ @R. You should always have remote journals stored in a separate library to the source journals. For the remote receiver library, we will enter Bravo_Journ @R, as we prefer to keep all of the journal objects together. We prefer to use Type 2 journals, which allow us to cascade, but it is also possible to use Type 1. For Journ message queue, we will enter the message queue we just created. Delete receivers we will set to no, because we want to manage the receivers manually. Pressing enter will add the remote journal. Refreshing the page by pressing F5 will now show that the new journal is inactive. Eventually we will start the journal, but for now we will leave it as inactive. In the next video, we will demonstrate how to create remote journals using the commands provided by HA4i. See Journaling for IBMi Part 2 for more instruction. Thank you for following along.